Good morning, everyone. Welcome back to our live stream, Saturday morning episode. We welcome everyone to this August morning. Thank you so much for watching us. I'm Irina Solovianenko, and I'm a managing partner at Access Machinery. I have here with me today Andrew Vicente, our application specialist. And we also are honored to have here today with us Chris Pilcher with the IPG Photonics Corporation. And the topic of our today's episode is fiber laser evolution. IPG Photonics is celebrating this year round date, and it's exactly 30 years since the company was founded. And Chris is bringing us very interesting presentation about IPG products and the latest advancements in the industry. So we encourage you to stay tuned and watch the whole presentation. Please ask questions if there are any at the end of the episode or during the episode. And we also prepared for you two showcases to show exactly what fiber laser can do for your machine. And speaking about the machine, behind us is a durma fiber laser. And as we all know, what is the heart of fiber laser machine? Of course, it is resonator. And a strategic partner for durma, for the resonators, is IPG Photonics Corporation for many years. And Chris, please, can you tell us a little bit more about your wonderful company?
Absolutely. Thank you very much for allowing us to come and help out on the presentation. My background is I've been here for about 30 years in the industry working. I've been working with lasers for a long period of time in both welding and cutting and many different industries. I can be reached at cpilcher@ipgphotonics.com, and I can be reached at 905-379-6602. So we break into the slide presentation. We can go to the second slide.
Yes, definitely.
That'd be great.
So let's start the presentation.
Okay. And our mission here at IPG is to look at increasing fiber laser innovation and leadership throughout the world. And we're not going to rest until we, make sure that everybody has a laser in their household. From around the world, from global service and sales, you can see that we've got a lot of people worldwide, which will break into how many people we have. And IPG essentially makes the difference on influencing all markets and all market strength and allowing different processes throughout the world. Overall, we have 100,000 installed base of lasers throughout the world. Last year alone, we shipped 43,000 devices. Now, when I first joined IPG, we had about 2,000 employees. Now we're up to 6,000. Very impressive. 2/3 of the lasers in the world that are fiber lasers are manufactured and produced by IPG. And as Irina said, we've been here for 30 years, founded in 1990. And since the last 15 years, we're traded on the NASDAQ. Very strong stock. You might want to research it. One of the interesting things about going green is that we've actually had 28 billion pounds less global CO2 emissions worldwide by using IPG lasers in the last 7 years. We have a lot of patents worldwide. We've got 350 patents, and currently we have 430 outstanding. That includes 24 terawatt hours of electricity savings since 2011.
That's amazing.
Amazing numbers. One of the traditional lasers that are out there, and I was around for a long period of time, even embracing CO2 lasers and also flash lamp pump. And you can see by the slide here, you can see that the CO2 and the lamp pump systems basically look like, science experiments. They've got glass on the inside. You don't want to ship them anywhere. If you ship them anywhere, chances are they're going to probably...
I like that analogy of the science experiment. It truly does look like a tabletop one at a science fair.
And they had a tendency to break. Matter of time, the lamp systems would spend more time being down than they would up. But they were expensive, they were bulky, they were very unreliable, they were difficult to operate, and they were extremely inefficient. Let's talk about the inefficiencies for a second. When it talks to CO2 lasers, they're generally about 6 to 8% electrically efficient. Lamp pump YAGs are 1% to 3%. If you bought them brand new, 3%. After a while, you can get them down to 1%.
1%.
That's it. And you would actually find transformers outside factories in order to supply power to the lamp pump systems. They were costly, and maintenance was always there, and they were not scalable. On the flip side, you can see the product line of IPG. We've got a whole repertoire of lasers. The CW lasers, the continuous wave lasers, are used for strictly cutting. And now we've got quasi-CW lasers, which are pulsing lasers. Again, they're cutting with small, thin parts and do a lot of medical welding. We've got adjustable mode beam lasers, which I'll touch on to laser as one of the advancements that we have now. And also when we get into high pulsing picosecond lasers and femtosecond lasers, which are quite nerdy, but also find their uses as well. In any event, the IPG lasers offer very high productivity worldwide. They're compact, they're reliable, they're now robust. The efficiencies are 45 and going up to 50%. So if you want to talk about going green, it helps out there. Minimal maintenance. You just basically grab these lasers, you push them in the corner and leave them alone. Don't touch them. No maintenance. They're solid state.
That's right. I wanted quickly to ask a question about the maintenance, because maintenance becoming the critical point on purchasing any equipment. So let's say if we're talking about the percentage difference on the maintenance between, let's say, carbon dioxide or CO2 laser and fiber laser, what will be ratio on the maintenance?
I think it's very important. The telltale sign is that in the advent of CO2 or flash lamp lasers, there's been a lot of spin-off companies. Companies that technicians have left the company only to add more to the service because there's so much service out there that they required. There's nobody to date that has spun off any company from a fiber laser company to make their own company for servicing them.
Just to have a service people.
They'd go back, they'd basically starve to death. So.
Excellent.
When you look at it, IPG actually started in the communication industry. You can see here all these communication banks, all the billion miles of fiber optic cable that go across the world from island to island doing telephone communications. That's how IPG got its start. Just nobody thought that they would actually go and last that long, or that they could communicate that long, or that they would actually scale up to a higher power. Those were milliwatts. We went from milliwatts, we went to watts, we went to kilowatts, and now we're at hundreds of kilowatts. We've got enough power to take down rockets if you desire. So over there, we've got increased throughput, we've got improved quality, and you get improved quality by having more out there. Billions are out there now in terms of fiber optic cable. Superior reliability, and obviously by driving all these markets, you get lower cost. So. Sorry, just going to the next slide. When I look at the different areas that you can actually get to, you can get to different markets. You see up in the top corner. You see we get into the automotive sector. And in the automotive sector, we have lasers that are cutting on the end of robots. The nice thing about the fiber optic cable is that it has that flexibility, whereas if I had a CO2 laser, a CO2 laser has to be delivered by mirrors. You don't have to do that. I can put this laser at the end of a robot. The reason they didn't do that before was because the prices were too high. But now that IPG has driven the prices down, it's a lot more economical. So we cut with them. We weld in with them. We do roof rails on them. We cut bumpers. We cut plastic components for the seating as well. If I look at the batteries on the left-hand side, electric vehicles. Electric vehicles are a huge market now. And we're welding all the battery tops on the top of those, but also we have a new product that's called process monitoring. And while we're welding, we can monitor the process real time. So we know exactly how deep the weld is while we're welding. Very unique. In the rocket industry, we can weld up to 2-inch thick copper. You know, it takes 65 kilowatts, but we can weld that deep into copper. In the satellite industry, all the manufacturing for all the structure. In the oil industry, if you look at cladding as well, cladding is a big part of making sure in the oil industry, especially up in the oil sands. If you look at the oil sands, they've got a lot of industry that has wear characteristics. They want chromium carbide, tungsten carbide coatings on there, so we put a lot of protective layers on there. If we look at the handheld device industry and computers, we not only use our lasers to put them together, we use our lasers to take them apart. If we look at the medical industry, in the bottom corner, that's a stent. If you've ever had heart surgery or need your valves expanded, that stent is actually cut. It's nitinol and nickel, 50-50, and it will actually cut that stent and allow you to live a lot longer and live a lot better.
What an amazing insight into the technologies laser can be used in.
It's a very fine, sharp tool.
I think that right now it's very hard to find a product without use of laser.
Yeah, it seems that way now.
Absolutely. And when you look at material processing, for instance, there's different areas that we can get into. We cut, we weld, we braze, we drill, we clad, we have additive manufacturing, we mark, and we also have surface treatment. And when you look at additive manufacturing is a bigger market, it's an expanding market. These are items that essentially you couldn't machine before.
And now, technology amazing with the additive manufacturing.
Yeah.
I'm seeing essentially you can 3D print metal. I know that's probably the wrong term for it, but that's how we're seeing it. And it's amazing to see what that technology will going forward. And again, filling every household with one of those. Make their own parts.
We'd love to. But it's an interesting point is that the lasers that actually go in those systems are a very small spot size. Those are our single mode lasers. And in the single mode laser, it's basically a 50 micron spot size on the part, and your powder is consolidated by that 50 micron spot size. So it does a fantastic spot.
It's incredible precision.
But even when you look at laser marking, most people as well are looking at laser marking components for keeping track of them now.
That's right.
Putting date codes on them. They want traceability. It will do that. If you pull out your wallet photo from your driver's license, that is done with the IPG laser marker as well. So we just advance to the next slide. We can see new systems. But all the major manufacturers, including automotive and semiconductor industry, as well as aerospace with Boeing, they're all a big part that are doing this now. So. You always wonder, how does it actually work? The fiber laser is an important part on how do we actually generate the light. The more important thing is that with a CO2 laser, you need a gas in there. You need the CO2 gas in order to generate the light, and that photon that comes out of that is indicative to a CO2 molecule. This is solid state, so there are no moving parts. There is no gas. This is just an active core. So you see in the slide, you see a pink rod going through the center. That is the active core, and we dope that with an element that we call the terbium. And a terbium, when it's raised to its higher energy state, it doesn't like being there. And when it comes down to its ground state, it'll emit a photon that's indicative to a terbium. And as it does that, we essentially can pump, as long as we pump the diodes from the yellow light from the side, we can then create light. It's immediately that you can actually turn it off and you can turn it on. So when you look at it, you see in the bottom left-hand corner, you can see the diode packs. We call these the multi-mode pump diodes. That leaks the light in to the fiber core and it activates it. You'll see on the left-hand side, the high reflector Bragg grating. That's 100% reflective, and once the photons start to flow, in that nice little purple part, it'll start to go back and forth, and that's called the population inversion. And then on the other side, we've got the output coupler, and it's 30% of the photons will leak out, and that's your business end, and it'll leak out the side. But 70% gets reflected back in to make sure that it goes on and off. The important thing is that when we turn these photons on and off with the diodes, it immediately turns off the laser. It's got its own safety feature built in.
So we still work with a shutter on this?
Nope, no shutters required at all.
No, it's all digitally controlled.
Well, that's an interesting image. Andrew, have you ever seen how our resonators look inside?
Actually, it's amazing to see this. No, I have not seen inside because these things just keep working, so I've never needed to open one yet. I mean, they're very reliable. So, you know, I was just one of those things, as Chris said earlier, just push into the corner and you're good.
That's what we want. That's what we want to hear. This is the back side of the module. And you can see on the left-hand side with the blue hose coming in, that's water coming in and water going out. That goes right inside that aluminum core and just cools down that whole module. So on this side, you've got basically the active fiber, and it's just wound up on a spool. And then when you see the back side of it, these are the diode modules. So we basically put these on the back plane, we couple them to them, and they're water cooled. Each one of these is a single emitter, and because they're a single emitter, it makes sure that they're very efficient, and there's a lot of redundancy built in here. There's a lot more modules, or a lot more diodes than you need. The diodes themselves have a mean time between failure of 100,000 hours. 100,000 hours, 100,000. So what that means is that if I ran, you know, 3 shifts a day for 20 years, that would be 100,000 hours.
That's impressive.
So we expect that to last a long period of time. So each one of these modules will then output a 2-micron fiber that you see is the orange fiber coming out. So when I tie them all together, so I've got all these modules, and we always put in an extra module. So if you get a 10 kilowatt system, you'll get 1 extra module. If anything does lower in power, the other modules will pick up the slack. Now all these 2-micron output fibers are then coupled together in what we call the combiner. And then from the combiner, it goes to your feeding fiber, and that goes right to the head. So that goes through all your edges, all through your axes, into the head, and it selectively goes there and stays inside the head. No reason to take it out, it works. The modules themselves can range from 500 watts when we first started out, up to 2,000 watts now. And all in the form factor of something that's about 9 inches high, 2 inches wide, and about 12 inches deep. So they're getting more and more efficient as we go. So you can see how scalable it is. The biggest laser that we've made to date is about 100 kilowatts.
100 kilowatts.
Yeah, and we've got some military applications as well.
Of course it is.
That if I told you about, we'd have to, I know that none of us could leave the building, but everything.
No, I have plans for the weekend.
That's right.
If you have plans, so it's nice out, so we want to go home. It's also upgradable. We have redundancy in the diodes, we have redundancy in the modules, and all of them are field replaceable as well. So when we look at this, it just adds to the simplicity of the system. So when you look at the fiber laser, oh, sorry, we went back to a different slide. So when you look at it, they're all built inside of a standard cabinet. And the cabinet is, basically it's dust-free, it's hermetically sealed, it's a NEMA enclosure. And on that NEMA enclosure, it can go off to, it can hide itself. There we go. All right, so you can see how we stack them up. So the power supplies on the system are advanced, so if we turn off the power supply, within less than 100 milliseconds, it turns off the laser. As long as, since photons make photons, you turn off light, it's gone immediately, so it extinguishes it. The efficiency of the diodes are the highest fiber efficiency diodes in the world to date.
Highest efficiency.
Yeah. So this is an interesting diagram, which kind of tells you a little bit more. It's something that we may want to spend a bit of time on.
This is my absolute favorite slide that shows variety of lasers
And CO2.
and CO2.
That's right.
You know, it's nice to see where they are. Not one laser is going to take over the world. That's an important thing that we really should understand. There'll be a market for everything, but there's going to be a sweet spot for most. We produce UV lasers, and UV lasers are more of a surface interaction laser. We produce, you know, red, green, blue lasers, and you'll find those at you know, IMAX and companies like that, mainly for you know, showing the movies.
Oh, that's wild.
As well.
Projectors?
Projectors, absolutely.
Mm.
When I said earlier we dope that active core fiber with a terbium, that's a 1-micron laser. And that allows us to deliver the fiber down a fiber optic core. It's wonderful. So it gives you that flexibility. But if I then take that active core, instead of putting the key element of a terbium in there, I put in erbium. Then I'll get a 1.5 micron wavelength. Well, we find that erbium has a different market. It may be some medical applications. And if we put in what I call a different element, I call it actually pixie dust, and we dope that glass fiber with a different element in there, in this case thulium, we'll get 2 micron. And in that case, we'll be able to weld plastics, because it now can absorb into plastics. But if I go all the way to, a CO2 laser, a CO2 laser can cut wood. A 1 micron laser can't. If I look at, I'm into the green laser. Green lasers, they say, couple better with copper. But if I hit it hard enough with a 1 micron laser, I can do the same thing as well. So fiber laser can hit that market as well. So it's really not out of our regime. When it comes to the different markets out there, you have to try it, which is why we have labs all over the world. So not only do we have different lasers that can hit different markets, you also can adjust the timing on them. If you look at for cutting, they're called continuous waves in the bottom left-hand corner. That is a continuous wave laser. It can cut, and it can weld, and it can solder, and it can drill, and it can braze. If you look at the next one up, a pulsing laser, or QCW line, it can do some very, very fine cutting. A lot of medical cutting, a lot of stent cutting is done with the QCW laser, and including the single mode laser. It can also do soldering, splitting little ends, but it can also drill. So if I see in the drilling example, that's a section of a combustor in a turbine engine, jet engine, and it will cut that. It will drill all the holes. If I look at the vector thrusters for steering on aircraft, they have 10,000 holes in them. That's a lot of holes to punch through there.
That's right.
And it can do each hole at about, sounds like a machine gun when it's actually cutting. Because each hole is done at, 1 hole every half a second.
Amazing.
I would like to ask a question here, if I may.
Yeah.
We often get approached with the question if our lasers can cut metals with some vinyl on it, because again, in the medical industries, they usually process materials with already some
Exactly.
material on it.
And this is where, it's important to test it out in our lab. We have labs just set up for this. We've got 24 of them worldwide, just to test it to make sure it can absorb into the material. If I look at the 1 micron for, absorbing into mild steel, those photons absorb better than CO2 at 10 microns by a factor of 3, which is why we cut faster, which is why the cut on thin metals, below 3 millimeters, it can cut through at high speeds, and if you're still cutting with CO2, you're not competitive anymore. So it can be a problem for you. We apologize, but it is there.
Apologies accepted. Thank you.
But then again, when the fiber first started out, the market was always CO2. It was predominant with CO2. And they said that the fiber laser, don't worry about it, it will never cut thick materials. Well, this year we've been able to cut 2-inch. So never say never. As soon as you challenge a new science, never say never.
That's amazing. That's been the main counterpoint to the fiber lasers have been CO2 handles thick better, but do you know something?
Yeah, it'll get there. It just depends on how much patience you have and how much technology is out there. So as I advance in the nanosecond lasers, those are good for marking, those are good for drilling. If I advance up to picosecond lasers, now we're really getting quite nerdy. But these ones will do thin film cutting, they'll do sapphire cutting, and even a screen on a handheld device. They can cut that as well. So, and then when we get to femtosecond lasers, it's even high precision. It will do micro cutting on circuit boards, and it will do other things as well.
Femtosecond. Never even knew it was that short.
Oh yeah. And part of the thing is that the advantages of the IPG fiber lasers is, number one, we can now hit the highest powers in the industry. It has the record power efficiencies out there. Beam quality is unsurpassed. When you get down to 9 micron spot size, that's the diameter of a human hair. That's pretty small. The fact that they're modular, scalable, architecture is so easy to change. The fact that they're reliable. Our warranty now is 3 years right out of the box. Nobody offered that before. Faster processing speeds by having a smaller heat affected zone. Lower operating costs. Easy systems to integrate. You want to communicate with them. DeviceNet, Ethernet, Profibus, hardwire I/O. It's got a smaller footprint. And at the same point in time, the electrical efficiency is fantastic. But of course you wonder, how does it do the cutting? And Andrew, you know a lot about this as well.
That's
you
right.
Can see, this is probably one of your favorite slides.
Well, that's absolutely right. I mean, as you know, you've seen me on the streams before, I've talked a lot about laser cutting. So I'll just take over for a minute here, is that we talked about the spot size here, and how is laser cut? Well, in the simplest form, essentially, the photons hit the top of the material, vaporize the metal on top, and essentially it vaporizes all the way down to the bottom of the material and is ejected with a cutting gas. That's the simplest form of it. Of course, as material thickness changes, material type changes, different interactions happen, but that's the most basic explanation of it. So with this small micron beam here, as Chris was talking about earlier, we cut so much faster because it's so much more focused, especially in that thin material where you really need it focused in a very small spot size anyways, because you don't need the strength through the entire material. You just needed to hit it and go right through, and that's it. So again, as we were talking about here, it depends. You can see there with the increased intensity, you have your solid state heating, melting, evaporation, and like I said, the ejection or sublimation of it.
Absolutely. And how you do that also depends on the absorption of the photons
That's
and
right.
whether that material likes that photon, and also the thermal properties of the material, which
Yeah,
is why when it comes to aluminum, you need a lot more power to cut aluminum just because of its thermal conductivity. So, you know, how you match that up also, you know, is established by good cutting charts, not welding charts.
Yeah, good cutting
You can tell
chart,
I'm more of a welding guy in
Yeah.
a lot of cases, but those cutting charts are very, very important in how they're set up in the machine as well.
That's right, absolutely.
So when I look at how the different types of cutting, it's a chart that it shows you there's 3 different types of cutting out there. Inert gas fusion cutting, right? Where we actually use an inert gas, whether it's argon. We've used argon in the past.
Oh, yeah.
We've used, I like to use nitrogen because it's
That's the
so
most
cheap,
common. Yep.
right? But it actually, the laser's just there to heat up the material.
That's right.
We're basically what I call a glorified flashlight. We turn ourselves on at the right time.
Yeah.
We can pulse, we can control ourselves beautifully, but we still need other assists.
That's right.
We need to know how fast we're going, how focused we're going. But the power density that we put on the part is usually about 100 times stronger than what you'd find on the sun, which
That's a lot of power.
is a lot of power.
It's like taking a magnifying glass to an ant, but times it by 1,000 or more.
I used to do that a lot. But the second type is essentially the reactive gas fusion cutting, where if I have oxygen in there, the oxygen acts as kind of a little campfire. And I walk that little campfire across the surface like they do in oxyacetylene cutting. And as I do that, it creates more energy and allows me to assist gas. You'll find that on anything that's 3 millimeters and above for a mild steel, but you know, there's also a hot, sweet regime in there where you use
Yep.
you know, just straight air as
Oh,
well,
absolutely.
compressed air. So don't discount air. Air has a lot of nitrogen in it. Air has a lot of argon in it. Air has a lot of oxygen in it. So I'm glad it has oxygen.
I'm a big advocate for air cutting. I've talked a lot about it.
Sure.
I believe it's the unsung hero of the laser cutting world.
Yep.
And I highly recommend asking us more about that because there's many advantages to air cutting.
Absolutely. And you save a lot of money
That's a big one.
as well, for sure. And then there's also ablation cutting. And this one is kind of unique. This is basically no assist gas. This is done with galvo mirrors, and the galvo mirrors will just basically project it down on the part. And as it does that, it creates enough energy on the surface, and that energy on the surface creates a plasma, and that plasma has enough energy to expel the material itself. It will do that layer by layer, so you can do blind cuts. We do that, you know, we've been known to do it in bone for surgery,
Wow.
which is kind of interesting. We've been known to do it in certain ceramic blocks as well, but it's also been able to do many things with respect to that. So when I look at the videos, so the first one is the inert gas fusion, and that one shows you the standard cutting and gives you a fantastic edge, and it's usually done for 3 millimeters or less. You can see it moving through the part. You can see it here doing a nice cut. mild steel, and it can also do aluminum and brass.
We're going to see definitely more cutting soon later too.
Absolutely. It can also do copper as well, right?
That's right.
Then when I go to the, the acid gas material, and I put the oxygen in for between 3 millimeters and 25 millimeters. And as I say, you can get up to 2 inch now.
2 inch.
Don't want to dance between metric and inches, but it does a fantastic job cutting. We can switch to the ablative cutting. The ablative it has an engine shape or piston shape, and it will cut through there.
That's amazing.
I've never seen it.
I've never seen that kind of speed.
It's not for the faint of heart. Not that one. So,
All right.
when you look at it, it's there's many different things you can do, and that's why we always say in the industry, never say never. If somebody says you can't, and you can't cut 2 inch, next thing you know, we're cutting 2 inch. But this is the new cabinet design. We've always looked at the laser as being the sharpest tool in the box. When you get down to a 9 micron spot size, it's fantastic. We have had our systems earthquake tested up to 7 Gs, and 7 Gs is like dropping our cabinets from 1 story onto the ground, and they survive quite well. So we've actually had them fall off of trucks, from bad shipping along the way. We've taken all the components out because the cabinet was destroyed, put them back in, and they work fine.
No way.
Yep, solid state.
That's right.
The only moving part that we have in our lasers, is essentially the chiller.
Go figure.
Right? That's the only maintenance that you have in a chiller. IPG has the luxury of being a vertically integrated company. And as a vertically integrated company, we do a lot of things ourselves that we've been forced to. Initially, we didn't get welding heads, and our suppliers were taking 16 weeks to give us a welding head. We had to make our own. We can deliver one of those inside of about 4 weeks. So if you look at the top corner, we make our own chips. We grow our own wafers. You look at the next part, we make our own diode packages. We're the biggest diode manufacturer in the world. We have our own mine that is a silicon mine. It is the highest purity of silicon in the world. We stretch our own glass. We blow our own glass.
Wow.
We take care of it. We put all that inside of our fiber optics. We have our own components for isolators, for couplers. We machine all of them. We've got 36 machining centers in our Boston plant alone. We make our own modules, as I say, up to 2 kilowatts now. And we package all of those inside of a very robust cabinet. And then, now we make our own cutting heads, we make our own welding heads, we make our own couplers, and we integrate all these into a standard system. That system is for ablation only, or welding, or drilling, or cladding. And that will keep an interesting thing. I purchased a laser myself about 20 years ago. That laser cost me $320,000, and it was 1 kilowatt. I look at the price of lasers now. You can see how small they've become. The form factor has been reduced dramatically. That first laser I bought would fill up a bedroom, an entire room.
Wow.
Now I can pick up myself a rack mount 1 kilowatt laser. They sell for approximately about $25,000 US, as opposed to the $320,000 that I spent 20 years ago. And what it means is that people that couldn't afford lasers before can now not afford to get into lasers. We've had markets that have expanded to us that you wouldn't even believe. And we sign non-disclosure agreements, and we test them in our lab, test different applications, and we move on. If you look at the form factor, by reducing that size, it's made them more efficient as well. So if we can look at also, not only do we get a smaller form factor, that as we move to the lasers, a 2 kilowatt, we used to say, our sweet spots that we're putting out were 5 kilowatts, 4 kilowatts, 3 kilowatts. Mm-hmm. It's now standard that we're putting out 10 kilowatts and 15 kilowatts. And we have a YLS 15,000 dash cut version for cutting as well. But it's not to say we can't put out a 25 kilowatt. And this has allowed the market to
Amazing.
keep increasing. It's now becoming basically a household name, which is kind of nice. So if you look at our diode production, you can see the what looks like a bit of a science experiment. But these are standard.
I can see that, yeah.
It is. Got different ports coming in and out of it under the vacuum, but it's all stainless steel and it's a very complicated component. But that's what it takes to grow wafers. We do our own lithography. We do our own metallization of the discs. We do our own optical coatings because, as you can see, optical coatings are very important when you're cutting copper, and the copper wants to reflect the laser back inside the system, and these optical coatings will retard that. Also, we get die wire bonding on the system, so the diodes can be metallurgically bonded. We get electricity to them. And then we are the biggest consumer of electricity in our plant because we have a big bank there that we've been burning diodes in since 1990.
Wow.
And we've got ones that are just sitting there just testing. So it is a building of just burning them in and testing them. And then we're highly automated as well, and we have highly automated testing. And we produced typically over 1,000 diodes a day, which is huge. So you look at them, we all package all of these into a very, very reliable system. And you can see that's a 30 kilowatt cabinet. So how many modules we just stack up? It makes the cabinet bigger, but as the modules get smaller and smaller, you basically can get the costs down. This is what's been happening in the industry with respect to the diodes themselves. By increasing the number of diodes that we manufacture, we've been able to gain very, very tight cost control over the diodes. And since that's the number one cost of our systems, we've decreased the cost by about 65%. We're the biggest consumer of diodes and the biggest user.
Wow, incredible.
So all this is to go green as well. You know, when you're looking at the flash lamp lasers and you're 1% electrically efficient, the world has changed. If you're still using a flash lamp laser out there, please call us.
Yeah, and I'm pretty sure that many municipalities will appreciate this as well.
Absolutely.
That's right, yeah.
Saving on energy.
It's amazing that you can increase the power so much for how much cutting, but we can also increase the efficiency. So
That's right.
It's an amazing thing that's been able to happen with this technology.
It's been a great goal, absolutely. But each time we do that, we make better steps for keeping the world green. In terms of new technologies, this is our AMB laser. We call this our adjustable mode beam. It's packaged in a system. This one here, shown in the diagram, is a 6,000 watt on the ring mode, and a 6,000 watts on the core beam, and 9,000 watts on the ring. And we can basically put in any combination of the shape. We can put the ring on the one side, we can put the core beam on the other side, we can make it go up and down, we can get full control over it. And what does that do? I mean, you can imagine for cutting, where you use perhaps optical zoom or anything like that. What do you do with respect to sharpening up that beam? So we can get larger spot sizes as well in there.
So I recognize this actually because I did a lot of CO2 back then as well, and we do mode shots. That looks like a CO2 mode shot.
It does.
Is that what you're making here?
That's what we're making here.
So that's how you're cutting 2-inch.
When you're looking like TEM modes of 0001 and stuff like that, it fattens up the beam.
Which is great for that thick material, huh?
Yeah, it is. It is.
Probably what is going to put fiber again ahead of CO2 on a thick materials, because there were lots of conversations about CO2 cutting faster on the thicker materials with the adjustable mode.
It just keeps getting better.
It keeps getting better,
amazing.
exactly.
But not only do you want to do that, when you actually look at that, it's not only can we do that, we can arrange it differently in the fiber that's delivered. So we can go with a core that's starting off at 50 micron, which a lot of people can't achieve, and 100 micron. Or we can dance the ring mode to 150, 300, 600. And when you look at it, welding is great for the 600 and the 100. So we can get, when it comes to welding aluminum, we can go twice the speed. So we're talking 16 meters per minute in welding speeds.
That's amazing.
Phenomenal, right? So In the automotive industry, which, you look at some of the trucks out there that are going to aluminum, they get excited. Again, all while maintaining the electrical wall plug efficiency of 45%. But through that, we've got independent control over the core and the ring. We've got independent selection of the modules and how they want to react as well. And we've got full analog control for ramping up and ramping down. And by doing that, you get all the control that you absolutely need.
That's amazing technology, that one.
This one's unique. This is our high peak power laser. So if you're deciding you wanted to have a 3 kilowatt laser, this one will actually put out a 6 kilowatt peak. And what's important about piercing versus cutting? Does piercing have any importance in terms of cutting?
Oh, absolutely. It's the main thing that takes up your time, especially in the lower kilowatt range. When you're cutting mild steel specifically, you probably see that peck, 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 peck. That wastes a lot of time. So, being able to peak the power up briefly and then go right through the material at 3,000 watts, it'll cut absolutely fine with oxygen cutting. And then you got the stainless side of things too, which with stainless steel cutting, the issue is that if you don't have enough kilowatt, it struggles to get through the material and it spatters on top. You get this nice little mountain you've probably seen. You got to maybe pre-cut that out or go slow to go through it and then continue.
Yeah.
So if we could just have 6,000 watts for just a second to get through it, and then we can continue cutting with a 3K, no problem.
Exactly.
So that's amazing.
And that's the good news. This one has 20% of the duty cycle is dedicated to that higher power. It still maintains the lower 3 kilowatt price, but you get that 6 kilowatt peak.
Wow, that's great.
So what happens? You get 2 times the peak power. You get cleaner and faster piercing. So let me ask you, Andrew, with respect to laser cutting, what happens to my cut if I don't get a good pierce?
You're not going to cut. You
No.
got to get through that material first.
And you'll see it sometimes, you'll see it start, you'll see it stop,
That's
you'll see
right.
it start,
That's
you'll see it stop. It's kind of like this little sea serpent cutting technique. It's there, it's not there. It's kind of crazy. But this will maintain that if it does pierce, and when it does pierce at that high peak power, it'll carry that right through the cut.
That's exactly.
And a nice clean cut. So you get, cleaner drilled holes. We also found that it's good for just drilling
Just drilling right
as well.
That makes sense.
You just want a hole of a certain size, 40 thou diameter, boom, you're all the way through it. So with that, you can increase your output quality. You get consistent and repeatable processing. Your finished parts look better. Your enhanced drilling capability gets cleaner, better controlled holes for thicker materials. You don't get that, what I call that spatter back in your face.
Yeah.
Right?
Oh yeah.
And when I reduce waste, I get shorter lead-in times on my nesting. I'm not eating up into the next piece my break-in point as well.
Of course.
And that can be found on the YLR and the YLS lasers all the way through, which is kind of nice. But this diagram shows you on the left what low peak piercing is versus what high peak piercing does. When I first established that pierce, it doesn't give me a clean hole through there. And as I say, I get some spatter back in my face, which means your cover slides get a little bit dirty and
That's right.
the end of your nozzle gets a little bit challenged. But if I can pierce through there, they last a lot longer.
And it's quicker.
And it's quicker. So piercing, you can see, usually can take greater than 0.1 seconds. But if I pierce properly, I'm down below 0.1 seconds, and I'm spending more time cutting and less time piercing. They get better
Amazing.
throughput. So when I look at that, this is what it looks like. You can see on a low pierce system, you see kind of it just shows you that it looks like it's got spatter coming back into your face.
That's very common.
Right? And you see that. We don't want to see that anymore.
Yes.
If you can get that peak in there, that pierce, you can get exactly what you want, which is, power to the component at that point, which is nicer. So typically worldwide, this just shows our application centers, and this is for testing those materials. So Irina, when you were asking about plastic,
Yes,
can we see through acrylic? We see through acrylic. We won't cut acrylic or weld acrylic. Plastics, some plastics, if it's darker, yes, but we go to these different labs. We'd like to try them out. In North America alone, we have 8 labs. This doesn't show manufacturing, but we've got 2,000 people on this side of, what I call the ocean being the Atlantic. On the other side, we've got another 3,000 people over there. We've got manufacturing in Italy, 2,000 people in Germany, manufacturing in Russia. We have 500 people there. And we've got all these labs all over the world for testing as well, and sales and service support.
Amazing.
So what we're known for is vertical integration to help you out. We're known for reliability and dependability. We have support. Have you ever had any problem us being out there on time to help install a piece of equipment? We've got service technicians in the Toronto area. We're always on, we've got parts, you know, spare parts if need be in London, Ontario.
That's right.
So they're already on this side of the border. No worried about, you know, getting it across the border and having a week in customs. They're there at your door immediately. We'll have a technician out immediately within, you know, one service call. We're there. And we've got high quality products, so we've got the proven experience as well to be there for you. I'd like to show you a slide just on the, this is a slide basically on silicon cutting. And on the silicon cutting, it can show you the, on something as fine as glass, right?
Wow.
Now the spot size on this is typically about 9 microns. And we're pulsing the living daylights out of it. And by doing that, you get these very, very clean cuts. And imagine, if you don't do it properly, this material will crack.
Immediately, yeah, that's right.
There's a lot of thermal stresses in there. But in order to peck that material away and do what we have to do in order to do that cutting, it's almost hypnotizing. And you can see how clean it is.
That's a high beam quality there.
Yeah. We also get into thick components. This is a titanium. And, this is, I think it's about 1 inch thick. It's a forged part. And as you can go through there, you can actually see as it gets into this cut, about 2 or 3 inches in, all of a sudden you'll see the separation here. Right here, all of a sudden it does a thermal shake and the material separates itself just because of the forge.
Wow.
But it will cut through very, very thick material. Of course, through that, we're using argon.
Yeah, argon.
Right?
That makes sense, yeah.
Well, titanium, if you get it oxidized at all, it's garbage after
Yeah,
that.
that's right.
So you
Yeah,
got to be
it
very,
loses
very
its
careful.
property.
But thank you very much for allowing us to come in and you know, show you the new technologies and what we do and where we're heading with respect to fiber lasers.
Thank you very much, Chris.
Thank
It
you for
was a very informative and impressive presentation.
Very informative.
Hello again. We've been here all the time, standing here. We are working on our process of inserting presentations in the corner so you can still stay interactive with us.
That's right.
As a host. Again, I would like to thank Chris for the presentation. Right now, I think everybody knows who makes best resonators in the world, and those resonators are used on our machines, on our equipment. And in fact, Andrew prepared 2
Right.
showcases, which again, this machine is featuring also IPG resonator on it. And Andrew, can you tell us a little bit more about
That's right. So
parts?
those are great technologies you showed us as well, but we have it on this machine at 2K because the main focus of this machine is to be economical but still very capable. This machine, as Irina said, has a 2 kilowatt IPG resonator, a 5x10 table, and of course with that IPG resonator paired here, we can cut many great things on it. And we're going to show you something right now. Here we go.
Excellent.
So as we talked about parameters, and Chris said of how very important it is to have the correct parameters, we are able to change it very easily with our saved cutting tables, and we can make adjustments here too. As we come down onto the material, this is 14 gauge stainless or 75 thou or 2.5 millimeters. So what we're cutting here is essentially a part that has a thread on it. And you'll see what I mean by a part that has a thread, because you're probably laughing since it's a 2D part, but you'll see here in a moment. When we're cutting through this material, we actually have enough laser accuracy and enough accuracy on the servos that are built by Durma, or paired with Siemens as well on the frame. The frame, the servos, the IPG resonator all work together to create the situation where we can actually laser cut such fine features as a laser cut thread on stainless material. Despite being 2K, as we said, with the smaller spot size, we're still cutting very quickly. On a CO2 laser, this would be more than half of the speed of this. beam quality also lets us pierce very quickly. Of course, we talked earlier about how we have there's a new peak power system where you can pierce even quicker, but even still in this material with 2K, it is plenty for this material. Despite me saying it's an economical machine, as you can see, it's very capable. We've cut many different materials on here, and ranging, well up to 1/4 inch on this machine when you're using oxygen cutting, and easily into the 10 gauge with nitrogen cutting. That's fine as well. So it's still very capable at 2 kilowatts. You can see the axes pulsing back and forth, dancing back and forth. That's the incredible acceleration of the helical rack and pinion paired with the Siemens drives here. You can also, we talked about linear systems as well. This would be a good example of a part where if it was on a linear system, it would be up to 2 to 3 times faster because it can turn much quicker. But still, we're quite productive here, and the accuracy is the important part. Continuing along the cuts here, where we're getting around to the end, where we're going to continue cutting. Still piercing through instantly, very stable, despite all the turns the machine had to do. This takes incredible stability to keep this going over and over again. You could cut an entire sheet of parts like this as well and not have any issues. Or on a CO2, you might start having issues with stability. Of course, the obvious point is as well, a CO2 laser would not be able to cut a feature as fine as this. And you'll see what we're talking about in a moment with this thread. All right, just finishing up here. Getting to the end of the material, find some final cuts here. All right, let's take a look at these parts. Very well cut, plenty of parts cut, no problem. So you can see what I'm talking about with the threads there. Let's take a closer look. I got a nut to put on. This is a 1032 thread cut with an IPG resonator, 2 kilowatt. Threads on, no problem. That's amazing accuracy on this part. So you can see how I laser cut a 2D thread, and there is actually some applications here. I mean, of course you can buy a bolt, but maybe instead of a weld stud, depends what the application is for. If you need some light duty holding, you can play with that too if you want. I find it amazing. I'm just sitting there twisting it all day, but it's amazing what it's doing with the thread there. So that's the accuracy on this laser system. That's amazing that we're able to even come close to something like this. I couldn't even dream of this in the CO2 days.
And that's one thing, we can give you a sharp tool, but you still need the control.
That's right, still need the control, still need the stability, so it all comes together, and that's how we're able to laser cut a thread. Wow. It's amazing. All right, so we got another showcase too that will show off another advantage of an IPG resonator, a fiber technology. That is just not possible on a CO2, so let's see what this one looks like. We're going to start switching over to another thin stainless part. Again, parameters change very quickly. It's all saved in a database. Laser is just commanded what to pulse and how much power to give. You may have seen us do something like this before, and you're about to see. This is 22 gauge stainless, or 30 thou, or 0.8 millimeter. You've probably seen this one before. This one's called fly cutting. So here, because we don't have a shutter, we can pulse on and off the beam so quickly that you can just go between cuts without actually piercing. And being a 2 kilowatt, we're getting right through this material with a single cut here. So we just move the axes back and forth and cut circles without having to move the head up, cut down, and cut a circle. So again, this is a huge collaboration between a good axis system, a fast control, and a fast communication and laser pulsing from the IPG. Everything working in perfect harmony to be able to do this fly cutting technique, which in the end saves you plenty of time as opposed to regular cutting, and even more time compared to a CO2 system in this case. It's just amazing to watch the process go across. I always love watching this because it's incredible. These are 3/16 holes, by the way, so this is a great technique to be able to cut these holes as well. We're almost as fast as punching here, and we're going to have a lot less warping because a lot less, we don't need to touch the sheet with a tool or heat it up that way. That's over 50 holes that we've done here, and we've already just about finished this. There we go. 50 holes, no problem. We'll make one more. So as we go across, we're flashing across. We'll do some fly cutting here, very quick. The great part about fly cutting is that it's not limited to just circles. You can fly cut oblongs, squares, rectangles. You've seen the triangles on our previous streams, hexagons. There's many different things you can do with fly cutting here. And it's as easy as using the software, which will teach the control how do you do this. Again, despite being an economical machine, this feature is standard on this machine. It is built and ready for this. Those instant pierces are just amazing to create those holes. And they're very clean too, despite what some others have said, maybe that, you know, oh, if you pierce on the same line that you're cutting, you're not going to get clean. Yeah, well, we just talked about how when you have a high kilowatt, you can go right through, push the material out of the way, and have as minimal spatter as possible. That's how we're able to pierce on the cutting line here. Again, we're about to finish another 50 holes here in under 3 minutes. Look at that, and fast cutting speed around the edges as well. Nice and clean. Take a look at that. Looks great.
Impressive.
Now you see a resonator right there as well. Just give you a last little shot of that. That's our 2 kilowatt resonator in our IPG. So not quite as fast as ablative cutting, but available on the machine and standard. And of course, because you can go with thicker materials than this, of course, just depending on your kilowatts.
Right.
So that's why fly cutting is an excellent, excellent addition to the machine. This is, by the way, this is a drain cover for a hotel. You'd fold these corners in, push it down. Here's your drain cover.
Fantastic.
Take a look. No burrs at all. Very minimal spatter on the top.
You mean for the shower?
For the shower, that's right, yeah. You know, you've seen those fancy, they put stainless and chrome everywhere. Yeah, it's a drain cover. You push it down and there you go, there's your drain cover.
That's impressive.
It is very impressive and all allowed by the IPG resonator.
50 holes in how long?
50 holes in about a minute and 30
seconds?
seconds about, yeah. So very, very quick cutting.
Excellent.
Perfect.
Thank you so much, Andrew. Great job.
Yeah, no problem.
I believe we covered all our topics that we
That's right.
plan to discuss today. And we can move forward to the questions.
Please.
We have several questions.
Oh, I love the question.
That's nice. First question is from Aaron. Thank you so much for asking. Can you specify lifetime of the IPG resonators? So probably lifetime of the diodes, right?
Yeah, lifetime of the diodes, but even then the diodes themselves have redundancy built in. So in any unit, it's got a lot more diodes that are built in there, and the different chains that go down to the resonator. There's modules that are in the system that are also redundant as well. So sure, we can say that there's, 100,000 hours mean time between failure, but we really don't know how long they're going to last, 20 years from now. This is why we're allowed to put out a warranty that's 3 years right out of the box, from date of shipment from IPG. But in addition to that, we also have the ability to, and we do, if you want to extend your warranty, you basically just give us 7% of the laser cost to headquarters in Boston or Germany, where we happen to be at that point in time, wherever you're situated. And you can do that, get another year warranty. You can do that up to a full 10 years. So
that's very useful information. So whoever is watching us, and if you currently have a machine that has already IPG resonator, you can extend your warranty or buy extra if you need to.
Absolutely.
Next question is from Kemal. Thank you. As I understood, QCW is better result for edge cutting. Did you offer YLR with the QCW mode?
It's a good question, very good question. And we have to be a bit careful here because the QCW is fantastic for thinner materials. So if I'm below 3 millimeters, it's going to give you a fantastic edge. It really will. And you know, when you're talking about limitations in power level, the QCW can actually, we have versions that are a QCW 150, 1500, which means it's 150 watt continuous. We have another one that's 300, 3000, 450, you know where this is going now, right?
I see, yeah.
We go all the way up to like a QCW 2000, 20,000. So it's got a 20,000 kilowatt peak.
Wow.
So generally we find those are better for, they're more in the drilling market, and people typically just take advantage of grabbing a 15 kilowatt laser or a 12 kilowatt laser for cutting, and they still get their peaks. But the QCW is a less expensive laser, and it will do it. It just depends on what your product thickness mix is, and your product material thickness mix is as well.
Makes sense.
Speaking of that, it's always the best to contact us with your application, with your manufacturing goals, with your targets, and let us guide you towards the best product that will serve you the best.
Absolutely.
Right? Okay, I believe we covered the second part of the question, right? From Kemal, if yes, power level is different during the QCW than CW. Next question is from Erwin. What are the resonator maintenance requirements, and does humidity electrical fluctuations, are they affecting IPG source? If yes, how we can protect our laser unit?
Yeah, so you break it into two. You've got the chiller, which has moving parts, and you have the resonator, which has no moving parts. And when you have no moving parts, you just keep it in a tight cabinet. It's air conditioned, it's enclosed. There's no need to open it up. Leave the doors closed, push it in the corner, leave it alone, no maintenance. Please don't try to do maintenance on it. When it comes to the chiller, depending on how you operate them, but typically we like to see the water swapped out every 6 months and the filters changed every 6 months. It's just good practice. You don't want any algicides growing in there that could clog anything up, but that's where your moving parts are. So it's a chiller.
And very easy to do.
But very easy to do.
Very easy. Next question, what are the differences between YLU and YLR units? And can you specify about cutting conditions? Are they exactly the same?
The YLR unit is what we call a rack mount unit. So, and they only go up to 4 kilowatts now. So they keep, 3 years ago, they went up to 1 kilowatt. Now they go up to 4 kilowatts. So
wow.
As the efficiencies go up and the form factor gets smaller, they're going to get smaller, and the rack mount lasers are going to take over more of the market, as we know. But the difference between the YLR and the YLU, they're both the same key components on the inside, and they both perform exactly the same, and you can program them exactly the same and do exactly what you want. So same beam quality, same everything.
Excellent. And one more question from Chris Morrison. Can you tell more about adjustable beam mode? When is it going to be available?
It's available now.
So it is available with the IPG.
Mm-hmm.
Very good. It is work in progress on our side with Durma. So please stay tuned. We will keep you updating about new products releases. And we believe we're going to make the announcement very soon.
And we'll shoot an episode about it.
That's right, that's right. And I'm actually also very excited about the high peak resonators.
Yes.
I think many customers will really appreciate it, especially those who are not specifying in very thick materials, and there's no need for them to get larger capacity, and it's just for the piercing.
Yeah.
So
especially on the 2 kilowatt.
that's right.
If you get a 2 kilowatt with a 4 kilowatt peak, you get the cost of a 2 kilowatt because they're relatively the same. It fits inside your machine. It's a very small form factor, and by doing that, you get the benefit of a 4 kilowatt peak, and
That's
you can
right.
get through there a lot faster.
So an HDFS with that
Yeah.
economy machine, piercing times of a 4K, speeds of a 2K. I can't
Excellent.
wait.
Oh yeah, no, me too.
Okay, I guess we are done with the questions for today. And I would like to let everybody know that we set our new record. Our episode was 1 hour, 5 minutes as of now.
That's right.
We will go right now and celebrate it. Again, thank you so much for watching. Chris, thank you so much for being
you.
with us. I learned myself lots of new things.
too.
And I would like to give you a sneak peek for the next week episode. It's not going to happen at our showroom. We will be shooting at the premises of our customer. It will be press brake. Very exciting, amazing machine with the features that we didn't show before. For heavy duty operations, stay tuned. As always, 10 in the morning, a Saturday live stream. All our episodes are also available in the post-recorded format. www.accessmachinery.ca. Thank you so much for watching again.
Thank you.
Have a nice weekend.